Clean, service, and repair Panasonic 5-way oscillation fan. This is the Panasonic F-1206 desktop fan. This was made in Japan. Very good quality piece. This is Russ's fan. If I recall correctly, this was one of a handful of fans that he got from his workplace for free. And it does not work. In fact, I think every single fan in that lot did not work. Kevin and I have repaired one of them thus far. Now there's 2 more box fans to go, and then this one. The box fans is just a simple mechanical issue with the bearings. This is potentially an electrical issue as well. This is totally DOA. Let's see if this is drawing any power at all. Does not seem to be. So we'll have to figure out where the power's stopping. Now unfortunately, some of these fans, despite being very good quality, some of these Panasonic and KDK ones, to my knowledge, used riveted shut motors, which makes the servicing a little bit more complicated because we'll have to drill out the rivets and then replace them with regular nuts and bolts. Oh, this is locked solid, so it probably has a tripped thermal fuse. This has definitely seen better days. The fake chrome is wearing off the plastic, leaving a rather unappealing looking badge. These are very nice looking badges when they're in good shape, but this can still be a very good functional piece once again. Wow, that is a thick shaft. Holy cow. That's the thickest shaft I've ever seen in an oscillating fan. 12-inch oscillating fan anyways. Wow. I think that's a 3/8 shaft. That's very unusual for a 12-inch unit like this. Usually the shaft is much smaller than that. Oh, like I said, very good quality. And this was put on there way too tight. Hope we can get this off without it cracking. This should not go on anywhere near that tight. It's just not necessary. Nice pitch to the blades too, very steep. It's going to be a very nice performing fan. No, this still has a stupid security bit in there from the previous project. Sticky Honeywell fan needed a security bit. It's a riveted shut motor. It's a pain in the neck. It really turns this into a servicing nightmare when it's like that. Alright, so that's an interesting design. Very clean electrical setup. Doesn't look like it has too many hours on it. Seems pretty clean. What a shame if this stupid thing is riveted shut. So now what we're going to have to do is we're going to have to drill out these rivets, and then we're going to have to I'm going to potentially have to go to the store and get some new nuts and bolts for this. I'm almost completely certain that this is going to be a thermal issue, but it doesn't really make any difference right now in terms of the disassembly, because we still need to free it up, which is going to entail getting this this motor opened up. And interestingly enough, it does appear to be as though there is some oil that's still liquefied on the front of the shaft here. So maybe somebody attempted to free this up in recent times, but this is not something that you're going to fix just from putting a couple drops of oil in there. This needs to be completely, thoroughly cleaned out, and you know, cleaned out with isopropyl alcohol and then polished and reassembled. So I'm going to take a quick break from the video and go see what I have in the garage, see if I have any nuts and bolts on hand, because I don't want to open this up without having a way to shut it again. I don't have anything on hand to put this back together with, so we're going to have to drill it out, and then I'll have to go to the store and get something to put it together with again. This is kind of a weird... Okay. I guess we'll remove this whole back apparatus first, because it'll be easier to work when this is not in the way. Wow. It's not coming, it's just stripping out. I don't want to do any more drilling than we have to. See if we can get a better angle on it by taking this off first. Just in case anything becomes disconnected here, I want to make sure we have a good picture of where all the wires go. It's always important to document how the stuff is before you take it apart, because there's no schematic, there's no service manual. You're on your own with this kind of stuff at this age. So you have to be able to recreate it and undo everything you do. Lots of excess grease in there. That's kind of a nice design. It all just comes out as one piece. It's pretty good. Make sure that doesn't get grease on my table. Okay. Now let's see, I have a better angle on these screws. Can I get them to break free now? No, I can't. They're just stripping out. Rats. And make sure I have the correct bit to the T. I'll use a fresh bit here. Oh, you know what? That's not the right size either. That's so weird. Okay, that bit's a good fit. I might have to get the electric screwdriver for just a powerful one. I can put more leverage on it forwards if with the other driver. Okay, that wasn't too bad. That's an excellent example of the importance of the right bit. Always want to use the right bit that has an exact fit. Very, very important. One more screw underneath here. It's too bad this is riveted together because I otherwise like the way this is coming apart. That's pretty good design. And now we can just detach this from the front entirely. Okay, so now I think we can probably put this in the press now. I have minor concerns about putting any force on this piece, so I'll have to try to avoid that if possible. I don't want to get this grease all over the drilling apparatus, so I'm going to... Where are those new scissors I found? I liked those scissors. Here they are. I'm going to cut a little bit of one of these bags off here and use this to keep the drill machine clean. See how nice these scissors cut? These are rare, something new, works good. But these work fantastic. Excellent scissors. So now we're going to put this in the drilling machine and get these rivets out of here. I'll use that to keep the machine clean. and I'm going to drop it through the back like that. I'll need to prop this up a little bit. Okay. No, that's not going to work. It's not taking any force. Normally I wouldn't put something on top of there like that, but no. What if it breaks? The guards should probably be able to withstand that. That's better. Okay. Now why is this not sitting flat on here? I was hoping this would just kind of sit flat on there, but it's not. There we go, that's what I wanted. Okay, so now we should be able to move this around a little bit. We should be able to maybe align this up correctly. No, we're not going to get that lucky with it. Alright, we'll have to go back to doing it like this. That's fine. Not what I prefer, but at this point, this whole operation here is not going to be what I prefer because it's stinking riveted shut. Alright, we're going to use let me use this one. How does this drill set work? The heck? This is the kind of stuff that's going to get caught on the uncut POV version that will not be on the regular camera version. So for you regular camera viewers, you might want to watch the other one too, because sometimes there's some funny stuff that happens off the screen. Alright, so let's get this bit in here. And that's great. Alright, and now we're just going to drill out each and every one of these rivets because they're stupid. And we gotta raise this up quite a bit. I can't really get a good, oh, that's kind of a decent view on the first one. I'll get a better view as we move to the ones in the front. You know what's annoying is that this base is not staying flat. That's part of our difficulty here. Oh, now it's too high. Well, okay. Now it should be the right height. Okay, get that right on there like that. Let's that's good. Move up the camera a little bit so we can potentially see what's going on. Oh yeah, there we go. That's good view. No rude comments. That is a very soft material. I may have to go with a much bigger drill bit actually. Huh. That's not ideal. I wonder if that's even close to popping off yet. This might be one that's going to put up some fight. I just want to see if this is even remotely freed up from this yet. Nope. Not in the slightest. Huh. The problem is I'm going to have to just keep going. I suppose, worst case scenario, what we could do is we could get screws that fit through here and just use these two holes. That would be good enough. Because what's going to happen is this is going to just keep enlarging, and then it's going to be too big and sloppy to fit a bolt through neatly. That's what I'm afraid of happening with this. But if that happens, it happens. We can't avoid it. This has to be opened up, and inherently these rivets are a very, very soft metal that's not drilling out as nicely as I would have liked. I think I'm going to try a larger bit on the next one and see if that works a little easier. I feel like we're well past the rivet at this point and into the stud. Well, let's try the next one. And I'll try a much thicker, a much bigger drill bit this time. Let's go for one in the front. So you can really see what we're doing here. I'll try I'll try this one. I guess I put this on a little bit too tight. Am I doing this backwards here? Must have been. Okay, let's see what we can do with this. Trying to go a little slower this time to not melt the metal. That looks pretty good to me. That's a good straight clean hole. Hopefully that's all the rivet, but I'm not certain that it is. It's gotta be. Okay, that I just felt that release. So that one's good now. That was what I was trying to get before. Let's go back to the one in the front. I don't think I went far enough. starting properly. This has turned into a mess, this one. That one's free. So 2 out of the 3 so far I feel like have released successfully. I didn't really feel that one release, but it's deep in there. Now let's see if the front shell is free now. Okay, we're free on this side here. This one I don't think that we got successfully. Oh, we did. Okay, so we got the front off. Now we got to get the back. Oh man, that was perfect. That was the best one yet, and I don't think it was in the frame. That drilled out perfectly. Maybe I should shut the camera off and then everything would go perfectly. And this one's going to be all stupid because it's in the frame. Ah, there we go. See how the rivet is actually on the drill bit right now. That's the rivet head right there. That's what I'd like to have happen. Okay, before we were done with the drill here, the drill machine, I want to clean this up, because that just looks bad. So we'll just take a large bit to that and clean that up. It's unlikely anybody will see it, but it's just not good work. That's all, just an extra 15 seconds to make it look right. Okay, now the motor should come apart. The windings are going to be stuck to the back shell because of the way the wiring is. So, why is this not? What is that hitting? That's kind of weird. I don't know if it's getting stuck on the windings or what. I guess we'll try to tap out the thing that holds the shaft, or the blade on the shaft there, and see if we can slip out the front instead. Okay, so I guess it's not going to slip out the front. It is hitting the windings. And that's exactly why you don't force it. If something doesn't want to go, you stop and find out why. You don't force it. That's how things break. Now it would be nice if I could get one of these shells to take to the store to get the size. So I want to get this size. Actually, I guess I could just trace this size into a like a piece of paper. So now the question is, how do we remove the windings from the rear of this motor with the way the windings connected to the shell? I need to separate. This rivet is not fully released yet. There we go. Okay, it looks like this plastic thing is just a placeholder. It's not actually secured to the windings at all. So we might be able to kind of finagle that through there. It's not going to be easy, but I might be able to do it. It's such a shame these units are so non-serviceable. This is a terrible design from a serviceability standpoint, but it's an excellent fan once it's running properly. Okay, hopefully the shaft at least will slip out through the back. Otherwise, this is going to be a servicing nightmare. 10 times more than it already is. Okay, so we need to look for a thermal fuse. Oh, phew, okay, good, it does come out the back. This is going to be our problem here with the lubrication. The oil is just dried up and it's not in good condition anymore. Okay, so we need to find a thermal fuse inside of here. I might have to disconnect all those wires to work on this properly and safely. I don't see thermal fuse here. Is this thermally protected? It does not specify on the tag that this is thermally protected. We might have to really? Is this not thermally protected? I don't see a thermal fuse in there anywhere. That's some kind of bug residue there. That's not an electrical component. I don't see a thermal fuse. Well, that makes this a fair bit more complicated then. Well, if this is not thermally protected, then I'm not really sure what is wrong. At this point, we're going to have to do some continuity checking here on the unit. So this is with the leads connected to both ends of the plug. Let's make sure we got a good... That's not a good connection. That's a garbage connection. Okay. So I'm going to cycle through the speeds now. And let's see if we get any kind of readings through the plug. I would expect not, but there's certainly other reasons why it might not work. Yeah, it seems to be absolutely nothing passing through the plug. No continuity at all. Okay, so now we'll check from some of these wires to the plug. We should get something at some point. Unless it's just totally busted. So this is non-polarized, so I'm not sure which is the high side. And we should at least get a common. Nothing from any of those. Let's try the other side. Nothing. I wonder if we have an issue with the wiring somewhere in the base. The fact that we're not even getting a reading on the common is very strange. Well, I think we're going to need to open up the base and take a look inside the base. Thought this was going to be fairly straightforward, but it's not seeming so. I had a feeling that wasn't going to be what holds it on. Okay, nothing too strange looking on in here. Let's see if we get any continuity readings in here. So let's find out which side. Okay, so that's our common right there. So, or we'll call that the high side. So let's switch over to the other side of the plug and check from here to there. So we know our cord is good. So the cord is not the problem. The cord works properly. Let's link up to the common here, which looks like will be the black wire up here. Whoops. And we're not getting anything. I'm not getting any continuity through yellow. Not getting any continuity through blue. And we're not getting any continuity through white. So there's no power passing through this wire, which is really kind of a weird failure. What the heck? And there is some electrical tape on here, which is always a potential cause for concern. I don't see anything weird going on under there. I don't see anything weird going on under there either. I'm no longer convinced that our problem is within the motor. To me, it seems like this stupid lead wire is just not carrying any power, but even that's a really odd failure mode. I'm going to go from white there to white over here. Okay, now I've got continuity. I guess I wasn't making a good connection. Okay, so let's check the blue. The blue is good. And the yellow is good. Okay, so our lead wire is fine. I don't know why I wasn't getting a good... I don't know why I wasn't getting a good reading before. Well, actually, our black is not... The black is not getting a good reading here. I'm not sure if it's because there's dirt on the connection or what, but I want to be able to see some continuity between because if there's a break in the common wire for some reason, well, that's not going to work, and the whole thing will not work for that reason alone. I'm not getting anything. Yellow's there. Blue is there if I can make a good connection. What the heck is up with this common? I think that might be our problem. I think we might have a bad common. It's not even getting the slightest amount of a reading there. Oh. Okay, I just put the puzzle together. This might be our thermal fuse. And if this is our thermal fuse, that would explain why the common's not working, because the thermal fuse has trip out. So let's open this up and see if that's the case. there's our thermal fuse. So most likely our thermal fuse is open. Yep, it's open. Okay, good. Well, not good, but that we can draw a conclusion now. So we know that our thermal fuse has spoiled. Okay, so now let's go ahead and bypass the thermal fuse for testing purpose. This is very neatly connected here. There's that Japanese quality. Just the same that it was not designed to be serviced. Let's see if we can read the value. $250 volts, 10 amps. Looks like it says 91 degrees Celsius. I think I have some 90s on hand. I don't know why I thought this was a good idea to put this away. I'm not done with this at all. It's not even the leads that I want on here. So now if we go and we grab that common over there, we should get a reading out of this. We're just not making a good connection here. Yeah, so we've got a connection up to here. Probably didn't strip that back far enough for that to work. Just use it as a placeholder for now. Okay, so now, if that is our problem, we should now be able to cycle through the speeds and get different ohm readings through the plug. The switch might be a little flaky, but we are getting some readings now. That's reasonable. That's reasonable. And that's reasonable. So we have a couple problems though. We do have an issue with the switch here. Most likely it's just a rust issue. It looks kind of rusty in there. We might be able to spray some deoxide on that and make it work again. Those contacts seem kind of corroded, so that's probably why that's not working properly, but this should be fine. Alright, well that's good. Now we understand what the problem is and what we need to do to solve it. So I will definitely have to go to the store tonight to pick up some nuts and bolts to close this. I should have some thermal fuses on hand. I don't think that they would have those at the store anyways if I don't, so it kind of doesn't matter. I do have some thermal fuse on hand, but they're not the correct specification. The ones I have are 115 degrees and this calls for a 90. So I'm going to have to order some correct fuses. However, we are going to finish the clean and servicing tonight because, interestingly enough, with the way it's designed, we should be able to install the fuse without disassembling the motor. So interestingly enough, had this not locked up from the bearings, we would have been able to just replace the... Is this wrong? We would have been able to just replace the fuse without all this trouble, which is ironic. They make the fuse easy to change, but the bearings impossible to service. Ain't that something? Well, actually, we shouldn't put that back on because we're going to have to service that switch again later, so I'll just leave this off for now. Okay, so let's get the shaft cleaned up because this shaft is really bad. We're going to have to polish this up, get this all cleaned off. This is really, really screwed up. We're going to need some isopropyl alcohol inside the bearings too. I forgot to unpause the video, but I just cut all this off so I can remove the shell because I was getting really nervous about this breaking. So now we can detach this from the project and leave this alone. Actually, we'll probably, maybe we'll revarnish it. It doesn't really seem to need it though. I don't really feel any loose. Oh yeah, there's a loose wire right there. But this is generally a very well made stator. Everything looks pretty good in here. Except for that. What's that right there? That's not good. Loose wires, and then is that can't tell if that's just a blob of varnish or if it's nicked. I have to look at it under the magnifying glass. Oh, it's hard to tell. I'm pretty sure that's just a varnishing defect. I'm not going to worry about it. So we'll put a coat of varnish over the motor, but it's not too bad. It's a very well made stator. Everything about this is well made except for this stupid riveted design. Okay, so now I can work on this, and I can work on this and not worry about getting the windings jacked up. It's got a lot of grease on the outside of it from pulling that bearing through. That's what happens when you have to pull the worm gear through. All that grease ends up getting on there. So we'll take the grease off and we'll have to put new in. This is the biggest part of our problem, all this gummed up oil here. That's why it's running the way it is. So we got to get this off and clean all this up here. Barely even comes off because it's so sticky. You would think it's a Honeywell product. I want to get the C-clip off of here so we can polish all the way down to the end. Even that's, look how sticky that is. Shouldn't be like that. I have to use a lot of isoprisol to get this cleaned up. You know what I might end up doing for this, because this is so bad? I might just go and soak it in hot water and dishwashing soap. That's what I did last time, and I seemed to have better results than isoprisol. I think I'm going to go do that. I'm going to go wash these with the dishwashing soap. Might as well do the back ones while we're at it as well. So it's larger, smaller, larger. That's the pattern it goes in. I better write it down. Where's the other clip? Oh, what the heck? Why is that all sticky? I gotta wash this toothbrush too now. Oh, this one has got that sticky stuff on there too. What is, and what, something was in here that was sticky. Must have been a Honeywell product. The stickiest brand. Yeah, it looks pretty good now. It's not sticky anymore. Excellent. Oh, no, we're not totally good yet. This one is still pretty bad. Wow, that is really stuck on there. Pretty much scraping it off at this point. Wow. That is quite an extreme case of gummed up oil. I wonder if someone tried to oil this at some point and used the wrong oil, because the back is not like that. It was the front, and that's probably where someone was most likely to try to oil it. You can only clean so aggressively here because it's only a little thin piece of plastic. Alright, I think we're going to leave it there. These are still a touch sticky. I don't know why. That did not clean it up as well as it has in the past. I guess this is just really, really bad. Yeah, that unfortunately was not as effective as I was expecting. So we'll have to keep going here for a little while longer. So we got to get these to the point where they're not sticky anymore, otherwise I'll have to replace them. Alright, that's pretty reasonable. That one looks fine. You can tell which ones were in the front and which ones were in the back. Yeah, the ones in the back weren't that bad, it's just the ones in the front. Yeah, I bet somebody oiled this with the wrong oil at some point. I can't imagine that the oil from the factory was good enough to last in the back, but not, you know, do this disaster in the front. That seems unlikely to me. Alright, that's pretty good. Alright, let's get this shaft cleaned up now. I like to put a piece of paper around the shaft to prevent it from getting chewed up by the chuck. Okay, this is not cooperating. Okay, the shaft has been cleaned up. It'll work much better now. There are some wear marks and score lines in there, but I'm not going to take it down to the point where we remove enough material to clean those off, because then the bearings will just be rooted, and that's not helpful. Now this did, the center there did fill up with simichrome polish. Doesn't really matter, but I'd like to get that out of there if we could, because it's very dirty. Okay, now we got to deal with the bearings. Those are a whole other mess, particularly the one in the front. You can see it's very dirty in there. Not good. So we'll get everything cleared out first as much as we can dry, and then we'll use isopropyl alcohol, and then I'll probably go around a polish in here too, because this was so bad. There's actually a what was a rubber gasket or some kind of gasket in there. No, I guess it wasn't rubber, but it is stuff with that stuff. Wow. Look at that. That's bad. Whatever this was, it's super sticky and it's very difficult to clean off. It's like turned into a tar at this point. Huh, that was originally a clear type material. Never would have guessed with the way it was in there. I don't think that this really holds any friction because this was on the outside. So I'm not going to go too crazy on cleaning this up. Just want to get it most of the way. Man, this is just caked in there. I haven't even gotten to the bearing yet. I'm just cleaning out the outer sleeve here. Okay, that's better. Now we've got a mess on the inside to deal with. And we're gonna have to put some polish in there, I think, to really get this to clean out. No, actually, it don't look too bad. Maybe it's okay. Nah, it's still coming out a little dirty. Okay, so what we'll do then is we'll put I gotta turn this around. That piece of paper is still in there helping us out. These are an extremely tight fit on there. Yep, that pulled a lot of the grime out of that bearing, hopefully. We'll rewash this with isopropyl alcohol in a minute. I gotta get another ticker towel. Still pretty dirty in there, but it's getting better. Alright, I think the bearing's pretty much clean at this point. So we'll take care of the back one, and then we're going to go to the store and I'll try to get some screws that we can use to close this back up. Yeah, that's pretty good now. Okay, I'm content with the cleanliness of this bearing. It looks a lot better now. That's the way it should look. Now let's get the back one to be in the same state of affairs. The back one's not too bad, but there is a lot of grease on the outside here, which we gotta get out of there. Oh, that's not grease. That's another one of those little plastic bearing things. Plastic washers, whatever the heck those are for. I don't know why they're on the outside like that. I don't know what purpose they serve. Yeah, see how much easily that one cleaned up? Definitely was a different type of lubrication in the front. Now the back bearing had no problems, so we shouldn't really have to do anything too obtrusive here. We did get a little bit of grease in there from the sliding through of the shaft. The grease does not belong in there, so we do want to get the grease out, but we won't have to do anything anywhere near as evasive as we did with the front. I think just a little bit of rinsing with this Prisl should be adequate. Yeah, it's already coming out pretty clean. Yep, we're good in the back. Alright, so the back bearing is clean. The front bearing is clean. Now we got to deal with closing up the motor again. So I have on hand, which I want to see if these will fit because I can use these. I have some 632 screws. This should be long enough, I think, for this operation here. So we're going to go through, we're not going to go through the original holes because they're all messed up now. We'll go through these two, which is kind of convenient that it has those. So that's kind of a loose fit. I'm going to go in the garage and see if I can find a screw that's more of a tight fit, and then I'll bring that screw to the store for reference to get new ones. Well, I think what I'll do is I'll bring these to the store, and if I can find ones that are a touch bigger, maybe I'll get them, but I guess it doesn't really make any difference. I thought it would momentarily, but oh, I just lost camera number 2. It's not going to really make much of a difference. It's going to be a pain in the neck either way. So I'm going to get some screws now, and then we'll be back on this video. Okay, I got the software. I got some lock washers. I got some bolts, and I got some nuts. And these are expensive. These are about $3.50 a thing. It's kind of ridiculous. And probably making these in China for 10 cents a piece, so they're making them in Taiwan for 10 cents a piece. Well, it'll get the project completed. So we're going to clean the shaft off one final time with this Prisl alcohol, and then we're going to reassemble. Just make sure everything here is nice and clean. You don't want to have any problems. No callbacks. Alright, so now we're going to add some new clean oil to the bearings. The oil is going to go inside where this felt material is, this stuff here. This is where the oil go all around here. This is a wick, and this will hold oil, and these bearings are called cinder bearings. They have microscopic pores that allow the oil in the wick to seep through the bearing into the center there, into the shaft during operation. So it's kind of like a continuous lubrication system. I'm going to use the Zoom spout oil, which is the original, and this is in fact for electric motors. It's paraffin based. It's made in USA. Very good oil, non-gumming. That's very important, because what we saw here was a ridiculous amount of gumming, and we don't want that to happen again. This will probably take a lot of oil. I'm sure this has probably not been oiled in decades. This has got a nice big wick too. This is going to take a lot of oil. You can actually see the bubbles coming out there as the oil replaces air inside the wick. Alright, that should be a good amount. Now we'll add some oil to the other bearing, which is still attached to the rest of the fan. This is not absorbing the oil as well as the other one was. So I don't know if maybe the wrong type of oil was stuck into the wick too. I don't know. I guess there's really no way that it could have gotten there because of the rivets. I don't know why this is not working as good as the back one is. That material can be replaced at some point. Maybe this will need it replaced. It's not an easy process though, and on this particular motor it looks exceptionally difficult. A lot of times on these things there is a piece here that ironically is also riveted on that holds all this stuff in place, and this doesn't have it. It looks like it's just press fit in there perhaps. I don't know. No, I ain't doing that. We're gonna go with the wick that's in there. I don't usually play with that. I don't think it's necessary. It's beneficial, but I don't think it's necessary. Okay, now we got to put the washers and so forth back onto the shaft. So we'll start with the clip. This is very difficult to get back on. I don't really want to force it with the pliers because you can always risk slipping and then scratching the shaft, but I can't seem to get it any other way. That's pretty reasonable. That looks so much better than it did before. It was awful before. It's pretty much good as new now. I still can't believe how thick this is for a 12-inch oscillating fan. I think that's the thickest I've ever seen a shaft for a 12-inch oscillating fan like this. Okay, and then with our diagram here, we know that it was one of these, which now turns freely, followed by one of these, followed by one of these. Now you can see the wear is on the inside of this one. I don't know if the wear would take place on the inside or the outside. Some people say, oh, you got to make sure you put it the same way. I say put it the opposite way because then it's like a new piece. Okay, washers are in place. Don't need that anymore. And we know those go on afterwards. I still don't really know what purpose those serve, but that's fine. Now we have to get the stator back in place. Oh, you know what? I haven't varnished it yet. I'm gonna varnish it now. Okay, I did not film the varnishing process on the regular camera video because it's raining out, but it is filmed on the uncut version if you're curious to see what it's like. So now we have to get all these wires back through this little organizer thingy. I don't know what that's called. I'm expecting this to be difficult, and that seems to be the way it's panning out. Okay, now I forgot which side the rotor has to enter this from. No, I was not successful in clearing this. Okay, now I was successful in getting that in place. Alright, I think we had said that it needs to come out this way. So that means this has to go like this. Yeah, it won't come through the front. So it's going to go like this. Seems like that piece has gotten bent down a little bit. It's not passing through the slots. The wire connectors piece. And it doesn't really bend at all. Why is it not going in there? This is such a stressful point in this process because one wrong move and you can snap a wire off and then it's a whole other freak show. I see what the problem is, I just don't understand why it's a problem. I also don't understand how to fix it. The problem is one of those solder joints is now way below where it's supposed to fit in. And I don't understand why it's like that. That's preventing it, you can see it in the center of the screen, that's preventing it from going in there. I don't understand why that's like that. Come on. Really? There we go. Okay, that was very stressful. But I think we've got it. I think it's copacetic now. would have expected that stud to kind of snap in place. I don't know why it's not snapping in place. I think it really needs to. Okay, it went. Okay, now we got to get this into the front. Would have liked to have put a drop of oil in there before we did that, but I forgot. I always like to put a little bit in there before we start, just so it goes in on a oily surface. Okay, unfortunately the battle has just begun getting this to close again. That's going to be a challenge. So what we'll need to do now is we're going to get our new bolts and nuts and lock washers. We just need 2 of these. I think what we'll do is how does this fit on here? That's a pretty good fit. That was what I wanted. I tried to get it as close to the size of the hole as I could, and I think that was pretty successful. So we'll do washer, lock washer, washer, nut, or bolt, or the heck it is, stupid inversion. I invert everything all day, it's so annoying. That's cool, it's got a measurement thing on there. I got stainless ones so we don't have to worry about it rusting at any point. And that's the last thing you want to do is fix something and then find out that it rusts next time you go to service it, and then it's a fiasco all over again. These washers are a bit too big here. Oh, why did it work on the other side but not this side? Might have to forgo the washers. I guess the lock washer makes enough contact by itself. That's probably good enough. Just make sure that the locking, the spring surface, the locking is actually up against the housing where it's got pressure on it. Alright, so we're going to rely on these old studs to kind of line this up where it needs to be. So these should go in still, even though they're not going to do anything like really significant. Yes, here we go, that just locked in place. So that's where that needs to be. See, this side is lining up nicely. The locking surface is where I want it to be. That's what I want it to look like. This side is not cooperating as well. Let's see if I can fix that. Looks like the motor is shut all the way around, so I don't think there's any other studs that need to be aligned. Just move the washer around here. Alright, good, that's where I want it to be now. So now we'll use an adjustable wrench and close it. I'm going to go a little bit more snug than usual because it has less bolts to hold it in place than it's supposed to. Don't want anything shifting around here. Okay, so that's in place. Now let's see, are we going to have an alignment nightmare or what? I expect to. But let's see, maybe not. Well, that don't feel right at all. What the heck? It feels like it's touching wires somewhere. What on earth is going on with this? What the heck? Something is totally wrong. And I have no idea what it is right now. Could it be that I just made this too tight? I don't see how that would. No, something's wrong. Something's very wrong here, but I have no idea what it is. Maybe it was just aligned that poorly. Sometimes when you have to align these motors without the original hole, it is a pain in the neck. Yeah, I think that was the problem. I think it was just a major, yeah, it was a major alignment nightmare. Okay. That's what the problem was. So what we'll do is we'll put these in, but leave them very loose for now. And then once we get it aligned up, we'll tighten it down. So at some point here, this will start to free up. So it's hitting the stator right now. It's not lined up properly. There we go. It's free right now, so we've got to get it screwed in exactly the way it is. I don't have a third hand to do this. Yeah, shifted out of place. Alright, so this is going to require an inordinate amount of patience here to get this to be correct. Okay, that just moved again. I think this has to come up like that. That's our problem. Might have to resort to a little bit of violence here. It's almost where I'd like it. That's where I'd like it, right there. It's not too bad. No, that's pretty respectable, actually. See if we can lock it in place here. Okay, that's still pretty good. Okay. Not bad. That was actually not as difficult as I was anticipating. Get this to line up as best as possible. Okay, I'm going to go with that. Let's get that piece put back in the shaft now, where it disappears. All right, let's throw the blade on there and see how it's working. Now I'm pretty content with that, especially considering I didn't put any oil in the back yet. Just put a couple drops to start in the back. And then we'll put this back for whatever the purpose of that is, I don't know. I gotta go change the battery in camera number 2. Okay, got new batteries in camera number 2. Add some oil in the front. That's pretty good. Oh no, I forgot this to put on the front. That had to go on before that goes in. I'll have to take that back out now. I don't know what purpose that serves, but I am not going to take a shortcut and just ignore it, because shortcuts result in failure. These don't have anything to do with it. Now, I really have no idea what purpose that thing serves. Seems kind of pointless to me, but put it back. The Japanese know how to design stuff. It wouldn't be there for no reason. Just the reason is a secret. Alright, so we're in pretty good shape here. That's good. I am content with that. Alright, now we have a wiring situation to deal with in the back here. So we have to reconnect a bunch of these leads. I did order some new fuses, so the fuse will come in a couple days. So we got the white connection, that goes to our fuse, the yellow connection, this connection, and then this is capacitor. So I got to get the soldering equipment set up, and then we'll reconnect those wires. Okay, now we're going to strip back all the wires, get it ready to be put back in place. Check this capacitor while we're at it. Make sure it's still good. It probably is, but might as well check it. .48, 4.5, that's probably good. Okay, so we'll reuse that. Okay, now we'll need to get some, shrink the tubing. We've got some small pieces in here that we can use. Would make more sense to put it on the other side and get it further away from the heat to prevent an accidental shrinkage situation. Hello? This we're not going to do anything about right now. We'll connect it temporarily just for a test, but that is waiting on parts. That piece is too small. We will save that for another project. This doesn't seem like it's hot enough. But it's turned up all the way. I can't get it any hotter. There it goes. This is not going to be a fun connection to make. How the heck am I going to do this one? I have no idea how we're going to connect this. I should have just desoldered this from the terminals itself. It would have been a lot easier than trying to patch this up like this. This is not stranded wire, so trying to make these tight bends here is very difficult. Well, that might be passable. We got to solder this really, really quick because it's so close to the shrink tubing. It'll probably shrink before I'm even done. I hate when that happens. Okay, not bad. Yeah, this was dumb. I did not leave enough to work with here. Okay, I think that's acceptable. It's not the best joint I've ever created, but it'll work. Okay, so what we can do to test it is we can just jump out the thermal fuse connection and run it without the thermal fuse. You know, just on a temporary testing basis. Before we power it on, let's make sure that we get reasonable readings out of our plug, barring any issues with the switch. There might be issues with the switch still. Actually, I'm pretty convinced there's some serious issues with the switch. Okay, that's a decent rating. Looks good. I guess we should check for ground faults as well. Alright, I have no reason to believe this is not electrically and mechanically sound at this point. Again, barring the issues with the switch. So, let's test it out. Oh no, I hate when that happens. I'm going to use a GFI cord just in case there is a problem that we haven't caught here. This might catch it before something bad happens. Okay, it's plugged in. Nothing crazy has happened yet. That's promising. Just tested that. Switch seems to be working okay too. Alright, let's give a quick test with the blade on. That is near silent. Alright, we know everything is okay, so let's get the kilowatt meter connected now. Make sure the power reading is normal. 36 amps, 40 the watts, that's pretty reasonable. 98 power factor, that's reasonable as well. Wow, this is such a nice fan. So quiet. Wow, that's pretty strong. Power information looks good. 1 on the nose for the power factor, .44 current, 51.2 power. That is really, really strong. Holy cow. Super quiet too. The Japanese really knew how to make a good fan, and pretty much everything else too. Alright, good. Very happy with that. So this is now kind of at a standstill until parts come in. So I could wash it. I guess there's nothing wrong with the switch. I don't know. It seemed like there was, but I guess it's fine. Not going to mess with something that's working perfectly, so we'll just put this back on. Some of these feet need some help. This one in particular. Yeah, these definitely need to be replaced. Yeah, that's not good having the screws protrude past. It's going to damage the table. Okay. Alright, so this is kind of paused for now until these parts come in. I can do the washing of some of these parts tomorrow, and then when the fuse comes in, we'll just put it in place. Very interesting design on this fuse. It, instead of being ingrained in the windings, it just sits right in here. It was just in here like this. It kind of goes underneath there and sits there. Very, very interesting. So that allows the fuse to be able to be changed without opening the motor, which is so interesting that those provisions are there. It's like it was intended to be serviced, but only to some extent. It's kind of strange. Well, this is going pretty good so far. There's not much left to go wrong at this point, so hopefully the fuse goes in easily and it cleans up nice, and we'll have a really nice example of this Panasonic 5-way oscillating the fan. I have some thermal fuses now. These fuses are 90 degrees. I think the original one was 91, so that's close enough in spec. Yeah, this was 91 originally, so we're down 1 degree. It's 1 degree safer. It'll work fine. So now we gotta come in the back here and figure out how to get this back on. I might reuse this part of the wire, because if I don't reuse this part of the wire, there's not going to be an equal amount of slack. So here's our new fuse. It's of unknown brand. Hopefully it's works and is safe. I never would really trust this 100% again, using these off-brand of unknown quality fuses, but on a hobby level, without getting ridiculously expensive, this is what we're using. I would not trust an oscillating fan unattended anyways, even with the original thermal fuse, because you have wire just endlessly flexing, which I think is a horrid design. Not good. I stripped it too much. I lost some of the original strands. Okay, there we go. That's better. So I'll probably join this back with this, and then let's see if we have enough slack after that. Yeah, it's close. It'll have to do. The soldering to these things gets very sketchy because you have to work super quickly. Otherwise, you'll trip the thermal fuse. You heat the wire up too much, it literally just blows the fuse. So you have to go super, super quick. It's kind of a pain in the neck. I'm gonna get some more heat wrap out. Actually, we probably don't, because we'll just put it back inside this stuff like it was originally. We will need to put a piece of heat tubing over this, but we can do that after I do the soldering. It doesn't matter because it's open on the other end. What the heck is going on here? Okay, we'll need a little piece of shrink tube for that. Okay, now the fun part of trying to solder on the fuse without tripping the fuse. This is not going to be easy. I wish I had some of these connectors on hand, but I don't. Have to lay it down. Okay, and we're going to focus on speed more so than getting the nicest joint possible, because we have very little time to work with. Okay, that's good enough. Well, not quite. Let's add a little more. Okay, that's good. And our little thermal sleeve is already on there, so that's okay. Now we'll come to the other side here. This one's a little bit further away from the fuse itself, so there's not quite as much urgency to this, but it is still a delicate process. Actually, that's pretty good. I think we'll go with that. Okay, that should be all the soldering that we have to do. So now we got to put this back in place. And before we do that, let's give it a quick test. Make sure that was successful. That was successful. It sounds bad just because it's scraping up against the, not the projector, what is that thing called? How do you call this? The capacitor. So the way this was before was this was just slipped inside here like this. And the fuse itself was just kind of stuck in here like this. Right up against the winding. Very, very strange design. I've never seen this before. But inherently it was effective because this experienced a thermal event and it did trip. But it sure is an odd design. There was clearly some intent to make this serviceable, but only selectively. Very, very strange. Well, we're ready to reassemble now. Do a little bit of assembly, and then we'll do some cleaning, and then that'll be a wrap on this. So here was the main gearbox. I think something else had to go on there first with it. Yeah, this part. So a lot of the grease has become displaced. So I'm going to take some of that grease, which is still plenty soft, and I'm going to put it back all into the worm gear there. Put it in there where that goes. And we don't want to have this come out. You don't want this piece to come out because it has these little balls that hold it in place, and when those things come out, they shoot across the room and you'll never see them again. Ask me how I know. I've dealt with that on many fans over the years. There's got to be quite a few of those little spring-loaded balls at the old studio. I've never lost any in here yet, but I'm sure the day will come. Certainly learned my lesson since then, though. Alright, so this went in here. How? Like this. So it does not have to go in place before. In fact, it can't go in place before this is screwed on. I'm not sure why I thought that it needed to. This is going to be a little tricky to get this started. There's a lot of stress on the wires right now. Something's not quite right here because it's not going down all the way. There we go. These gears should probably get some new grease at some point as well. Okay, now I don't remember exactly how the wires were routed, so we have to figure out what makes sense. This does not make sense because it should be on the other side of the arm here, so I think everything has to come around here. Getting tired of it doing that. So the capacitor is going to slip down in here like this. Definitely want to make sure that this does not come out of there. That would not be good. Maybe I'll put some cable ties around here to prevent that from being able to come out. I think that's a good idea. I'm going to put some cable ties. You know what? We're going to touch up this. This joint here is kind of getting a little dodgy, so we'll fix that while we're in here. But this is still going to go around here like this. Okay, that's not likely to come out of there anymore. really a good spot to connect the wire tie to. Kind of got lucky on the other side there, it's just staying in place nicely, but this one is not. This one's not going to hold. And there's very little I can do about it. It's not hopeful. Okay, this is not cooperating in the slightest. There we go. Alright, so this is a bit of a dilemma here because I don't know how to secure this. I don't know how to secure this to here. I don't think it really was secured any particular way before. Maybe if we go around here like this, perhaps. Yeah, that might do it, I think, if we do it like this. Yeah, that'll work. Okay. Yeah, that's just not helpful. Hate wasting materials. Especially because these aren't cheap either. These are high temperature ones intended for use inside electric motors. You get a lot of people complaining about me using these, but these are specifically for electric motors. Okay, that's good. I'm content with that now. That's nice and secure. That's not going to come off of there. I'll just leave a little bit in case we find that we need to tighten it later. Don't see any reason why we would, but you never know. So now we do have a slack issue, so we're going to have to kind of coil these up a little bit and probably put another cable tie to even this out. Alright, that's pretty good. Now, I'm not really sure what the original... Was there a... I don't think there was a strain relief of any kind here, but there really needs to be at this point. Maybe I'll secure it there. Trying to think of where the best spot to secure this is. I don't want the flexing to be on all the joints there. That's not setting up for success. I think I'm going to be most comfortable with that. Strapping it up there. This way it's got nothing to scrape up against. Yeah, I think something like that is our best option. Let's see how we can do this. I think that's pretty good. It keeps all this in place and shouldn't be any major chafe points there. I'm pretty content with that. Now let's reconnect the articulation arm. This is very difficult to get screwed in now because there's no angle to work on this. How in the heck did I get that off? I wonder if I disconnected it while I had the shell apart. I'll just have to go like this. This is going to take a little bit of time, but it'll get us where we need to be. If I get a better, would these be better? They are much better. Alright, now we'll do a little bit of cleaning in here, get some of this surface dust off. It's fairly clean in here, just a little bit of grime here and there. Not gonna be too worried about it. Alright, let's do a test now that everything is kind of back in place. And we'll kind of take some notes about how the circulation is working. Okay, so our circulation is on. The fan is not plugged in, and that's causing it to not run. Duh. Nice quiet low. The wire is only scraping against plastic pieces right now, so I think that's pretty good. Now this has, 5-way, so it's going to be different now. That still seems fine to me. I don't like that buzzing that's developed. I can't believe how much air this moves. That's crazy. I think this is stronger than the Lasco Galaxy ones. Alright, it's time to do some cleaning. We're going to clean the base with melamine foam as usual, and it's going to work good. All these pieces are kind of dirty. We'll get a new one. We'll use these for some dirty project. This is kind of a clean project at this point. Wow, it's like magic. Although whatever that is, it's making that worse. Nope, it just got better. It's not really yellowed at all. Heck is this stuff that's on there? Oh man, are you hearing that wind? Just makes it miserable to be outside. Which is unfortunate because it has been kind of reasonable to be outside the last couple of days, so it's unfortunate that we're back to this nonsense. Definitely want to make sure we don't drip any water into the buttons area. And I would not go over this with any significant amount of force or time with the melamine foam anywhere that there's writing, because it will take it right off. Okay, that looks pretty good. Certainly a lot better than it did. Now let's move on to the cord. And here's a part where I'll use one of those dirty pieces for. The cords you can often get to look pretty much like new with the foam. Oh man, listen to that howling out there. That's bad. And I'll probably get somebody in the comments box telling me that I ruined the plug because it got wet. Well, it's a molded plug. It's watertight. It's not ruined. Okay, so this is all cleaned up now. We'll move on to the rest of the pieces. That cleaned up pretty good. Let's get the base, or not the base, the motor housing cleaned up. Need that. Oops, I need that for the blades, that for the motor housing, that for me. Done with this for now. Look at that. It's like a miracle cleaning product. I've never used anything else that works as well as this. It's just incredible. It's so quick. It's so easy. And this stuff at the end here, this is going to take a little bit more effort to get off. Those are like deep scratches, it looks like. Got most of it off. This part we'll have to do with the brush to get into those creases. Ah! Where is that coming from? Oh no! I got some of the grease from the inside of it on the outside. Oh, rats. Ah, stinking skunks. I got it everywhere. That's not good. There must have been some grease on the inside that I brought to the outside. That's unfortunate. Alright, good, we got that under control. Look at that, it's like brand new. Amazing. Absolutely amazing product. I think that's where the grease was spreading. Okay, now the blade we are not going to clean with melamine foam. That is forbidden. We will just clean it with some soap and a ticker towel. It is forbidden to clean translucent blades with melamine foam. Okay, the rest of the pieces we will clean with melamine foam. Actually, this will probably clean with a toothbrush because it has a lot of indented parts. Oh, these guards are filthy. They didn't look that bad, but they're pretty bad. Not to worry, the melamine foam will clean it up perfectly. It's mostly just the inside that's dirty. I guess that kind of makes sense because that's the side where the airflow would come from. This guard I don't think would have been a shiny chrome, so you could probably repaint this and make it look like the original. I will leave that to the original, to the owner. I'm not much of a cosmetics person. I mostly just do the mechanical work. Just don't really take an interest in cosmetics work. Okay, it's time to reassemble. Oh, is this going to be a problem now? It is. Rats. That is a problem. Maybe not. Let's see. No, I guess it's okay. It is tight fit, but I think it's okay. We'll just have to make sure that everything lines up without additional force. If it requires additional force, then it's not correct. It's not ideal, but I'm not really sure what else you would do. I don't think this is going to work. No, it's not going to work. Okay, so we have to route the cord somehow else, but I'm not really sure at this particular moment what other option there is. It might have to just come all the way down and then sit at the bottom, I guess. There's not really a good option for this that I'm seeing. Well, we know this is not going to work, so take that off. We can reuse that for something else. There's plenty of that left. It has to be like that. So somehow the wire's gotta be on the bottom. All right, let me think about this for a minute. I think we're just gonna go with it as is. It's not flexing up where it connects on the terminals. Potentially this is a shave point here, but it's like a rolled edge. It's not sharp. I think we're just gonna do it like that. Pretty sure that's how it was originally. I have to look back on the video and confirm, but yeah, I think that's okay. Just want to double check and make sure after all this finagling, all the connections are still good. Looks like it. There's almost an issue with the washers on the side, the lock washers. This is a very tight fit in there. There's not much room for pretty much anything extra, nor would there typically be any reason to add anything extra in there, but it is very tight fit. You can actually see we're clearing this by Pretty much no extra margin. So that's how the cord is now. I think that's okay. I don't trust oscillating fans anyways. I mean, you got this whole wire moving up and down inside here. It's just, no, I don't like it. Don't like it any model. This cover's getting all dirty again from, actually now the scratch is canceled. That's not getting dirty again. It is going backwards again, which is mildly infuriating. Hopefully that stops once we put the guards on. Put some extra weight on the front. It says hanger there. I don't know what that means. Okay, that gets a 0 twice. Water in there, that's no good. It's looking pretty sharp now. These guard clips are kind of flimsy. Okay, and that's a wrap. Oh gosh, that was a pretty bad tripod kick. These have a really nice, quiet, slow, low. It's almost inaudible. Oh, that's great. It's in really good balance too, just about perfect. Yeah, I would say that is in perfect balance. Wow. Between that and how thick the shaft is, the bearing should practically never wear out in this thing. Alright, this is not Okay, there we go. All right, very good. This is repaired and working. It's a nightmare to service these things, but they are well worth the effort. It's an excellent quality product.